Thank you very much. I'm already here. It's a pleasure for me to be here and to talk in this very, very great symposium. So I'm happy, I'm glad. Thank you very much. I will talk to you to the way after the study, after the technology has been developed. So I'm talking about the application. And I will show you that one of the quantum technology already made its way into the application, and in this case, into space. So I'm talking about quantum communication or quantum key distribution. But first of all, I would like to show where I'm from and where we are working, and which might be a potential employer for some of you. So OHB SE is a company which has been founded some 40 years ago, and it's still a family-run company, and within Europe, we are the third largest satellite provider. We're different sites in Germany. OHB System is the largest one, and OHB System is with two sites available. One is in Bremen, that's the headquarters, and the other one is in Oberpfaffenhofen, so in the metropolitan area of Munich, so very nice place to stay. And with the OHB System, we are now in the competition with the other two large space integrators, and we have in principle three branches. One is the space system branch, which is shown here, and here we are with OHB System, but we have also some aerospace activities where Ariane rocket parts will be built and launched in Kourou, and we have also the digital part where we look into digitalization and where we also do applications for Galileo, for example. But with OHB System here, we have, as I said, two sites. In Bremen, this is in the vicinity of the university, and the one in Oberpfaffenhofen is next door to the German Space Operations Center, to GSOC and the Galileo Operations Center. We're doing the development and the integration as well, and the latest spacecraft we brought into space was NMAP. You might have heard about it, which is very successful, and this is really now, a positive story since 40 years. We are doing in all kind of missions. I don't want to go in all the details because I don't want to eat up too much time. I would like to try to save a little bit, but you see that we are really in all applications, and especially we are here looking now into security and also the quantum technologies, which is here in that part. So quantum key distribution. The question is why quantum key distribution? There was, to my understanding, no baseline talk yesterday on the technology, so I will just guide you very quickly through the thread. So quantum computing is a very nice development. A quantum computer is available, but not with so many qubits. But if the qubits will be in 1 or 2 orders of magnitude higher available, then the classical encryption can be broken, and therefore we need to act. So in the upper bar you see the security with classical encryption, and here in the lower part you see that there might be some time for migrating to quantum safe systems, and then there's the other part where it needs to be stored, so the long term. And when the time runs, and then at some point in time when the availability of the quantum computers is there with a real number of qubits, then everything which has been stored in a classical way is broken and is compromised and can be decrypted back to them. So in principle, we really have to act now. That's the point. And this has been realized not only by companies like us, but also by the EC, the Commission, and ESA. And therefore, they came up that we really need to act urgently. So the way out of this problem is quantum key distribution or post-quantum algorithms, or symmetric encryption would also work. We believe that the combination of quantum key distribution and post-quantum crypto will be, as a hybrid solution, what we have to implement later on. So this is what we are looking into. That's the idea of how quantum key distribution works. So Alice is talking to Bob. They have a classical channel, they have a quantum channel, and there's an eavesdropper who might look into the system. They exchange, so Alice and Bob exchange quantum information, and with different protocols, they can then do a key sifting. They can estimate if Eve was at work, so if some photons has been already detected by Eve, with some statistical methods, and after that with error correction and privacy implication, then everything what Eve might have seen is out of the solution. So the key which is then generated between Alice and Bob is a pure key, which there is inside nothing anymore, which could have leaked to an eavesdropper. So with this in mind, then with a message, it could be encrypted, for example, with a one-time pad, and then the encrypted bits will be available and can be transferred. And with having the keys available on both sides, then the encryption can take place. So now the question is, why shall we do this with space-based quantum key distribution? In the lab, it works already free space. It works also in fibers. But the limitation of fibers is that the attenuation is really limiting the distance, so about 100 or 200 kilometers. And with this, it's clear that larger distances needs to be gapped somewhere. Quantum memory is not developed so far that we can use it. We have some very nice posters here where the technology is shown, but it's not applicable so far. So in the meantime, so maybe 10, 20 years, there's the good opportunity, there's a window of opportunity for larger distances to gap with spacecraft, and therefore we have satellite-based quantum communication. And this is what is shown here. We can do this with constellations in different orbits, so in a low Earth orbit, medium Earth orbit, even from the geostationary orbit. Then the distance is very far again, but it's possible because the direction as seen from the geostationary orbit is very low. We have a couple of protocol pairs, so prepare measures, one entanglement base with another group, and we have different sources which can be used. Right now, for our system to be developed, we are looking into the sources. To show you how it looks like in a real quantum key distribution system in space, you have here this graph. So we have a space segment, that's a spacecraft. There we have the platform, which is just a simple spacecraft. Then there is an optical terminal, and we have then a quantum optical subsystem where the different quantum states are generated and then forwarded via the optical terminal to the user ground segment. The user ground segment then here has another quantum optical system, so they can then exchange and implement the protocol. And then there's a normal communication system which can then use the internet for communicate, for example, with another ground segment element. And if the spacecraft then moves from A to B, and this is prepare and measure, and then if the protocol is handled a second time, then after that both user ground segment elements can communicate with each other very easily. There are a lot of programs already running, and I'll show you here a graph which is part of the article in the Luft- und Raumfahrt, so the bulletin board, the bulletin of the German Society of Aeronautics and Astronautics. I don't show you everything, but highlight, for example, Meteus. Meteus is the one which is a very large spacecraft. This has already been launched, and a lot of principles have been shown that this is possible. It's a Chinese spacecraft built on the expertise which was generated in Austria by the colleagues, and they went back to China, and then they got a lot of money so they could implement it. And we believe now in Europe that we might fall behind, and therefore we intensify our activities. And for this, there is SAGA, or as part of the European Secure System for Connectivity. And this is what is to be implemented, and this is what I'm talking later for SAGA as one of the projects. And then there's also Eagle 1. Eagle 1 is a spacecraft which is co-financed by the industry. Leading is this by SAS in Luxembourg. There is TESAT part in it, and OHB, we will bring the quantum random number generator in part of it. There's also Cube or Cube 2, which will be a CubeSat. Cube 1 is built, and Cube 2 has just started. a few months ago, and their quantum key distribution technology will be shown, or in the case of Cube 2, we will show that the quantum key distribution from space can work. Yes, and there are others as well. But I don't want to go into the details. I would like to show you what the programs are we have done, so I'll give you just some rough information. So we started with a Skylight project. Skylight is an ESA-financed activity where we looked into the architecture of a space-based QKD system. This was a QKD for ECI. Here is Cube, what I meant. This is the connectivity initiative, and the connectivity initiative is the next communication constellation for Europe. And as part of it, there shall be the QCI system, the quantum communication infrastructure, starting with a service with quantum key distribution, but later it shall become the quantum internet, so European quantum internet, where exchange of entanglement states, for example, is also foreseen. But for the beginning, it shall be quantum key distribution. And there were two studies, so a very early study on the architecture, now running and nearly finished the one where the first layout of the system has been done. We are part in both studies, and we are one of the prime for the ESA Final Saga study. The Space QRNG is a currently running program together with the KeyQuant and spin-off of the Max Planck Institute Physics of Light in Erlangen, and QSync again, where we cooperate with also the Friedrich-Alexander University in Erlangen, Nuremberg, and also the LMU here in Munich. Additional projects are Canopies, which is the ESA flavor of the connectivity initiative, and there was SpaceQuest also, where we try to design, where we designed a system and tried to bring it onto the space station, where we could show that entanglement based systems can run, and that the gravity is not really an issue. QSync is a synchronization model I mentioned, and they go also into then QNet and OpenQKD, and we are also we founded the Deutsche Industrieverbund für Quantensicherheit, which is a conglomerate of German industry for quantum security. So this includes not only QKD but also post-quantum, and these are potential employers in the future, where we try to influence the community, the system, and try to build up a chain for generating this. So two of the smaller projects one is the QRNG we currently develop together with Antwerp Space, the FAU, and the AIT Fragmentex. We bring a quantum random number generator on the Eagle-1. Plan for launch is 24, 25, but maybe more 25. And Cube 2 is the CubeSat, which is a little larger than Cube 1. Here we are coordinating the consortium with some funds of the BMBF. We are prime, and we work together, for example, with LMU and FAU. The platform itself, so the CubeSat here is built by the Zentrum for Telematik, and the Institute of Communication Navigation from DLR, just in our neighbor plot, is developing and providing the telescope. But now to Saga. So Saga is the space part of the QCI system. I don't read this for you. You can do it by yourself. But I just want to mention that in April 2019, there was an agreement between the Commission and between ESA that they are going to build this system, the quantum communication infrastructure, and that ESA shall be responsible for the space part in it. So the space part is then to be understood as the QKD backbone of the system, where not only systems on ground are connected, but with a spacecraft, larger distance can be kept, and it could also be made possible to communicate, for example, with the capitals within Europe with their embassies around the globe. So this is possible. We are designing as one of the three consortia on the current system. We are nearly finished. In 1 week, we will have the final presentation and a business day in ESA, and we will show what the system should look like. And we expect also then the ITT for the next phase in ESA. We call it phase B1, where the development starts. And at the end of the year, after the ministerial conference for ESA, then the ITT, so the invitational tender, will start for the implementation phase, where really the first spacecraft is to be built. Yeah, the objective of the mission is to design, develop, and validate the EuroQCI space segment. We will then provide quantum cryptographic key material. This will be provided to the EuroQCI, so the EuroQCI in this case is to be understood of our customer. Yeah, this is the starting point, and here you see on the right-hand side the consortium. So our customer is ESA. We work together with Thales Alenia Space France, with AIT in Austria, and with SES in Luxembourg, and we have University of Padua and the DLR again here as our subcontractors, and we are nearly finished. OHB is responsible for the complete system and the mission. For the security part and the ground segment, Thales Alenia Space is responsible, and for operation services, SES as a large space craft operator, very well suited, and Austrian Institute of Technology, the AIT, they're responsible for the technology. This is what it could look like in our view for 2030 or so. Here we have the different spacecraft, and on ground we have networks with fibers and connect with trusted nodes, and then we have the different spacecraft. What we are going to do is to implement in the first place a prepare and measure based system, where the spacecraft is talking to two ground stations, not at the same time, but one after each other. And the entanglement part is where a spacecraft talks together at the same time to two ground stations with entangled photons. We also delivered a system where the moving spacecraft will be defined into which ground station they shall talk to. To our understanding, this is a future implementation or an opportunity for some quantum algorithms. We're not so far here, but this is at least what we think where in the future can be thought of. Yeah, and this brings me then to the announced Quantum Industry Federation for Quantum Security. Just one slide. We founded these to make sure that we really have an industrialized version for the quantum safe communication, and we want to make sure that the sovereignty is guaranteed in the technology point of view, and we work on building up a ecosystem and have different interfaces to the politics. We investigate also how to interact with other groups in Europe. We support fundamental research, and we do some public information. For example, I showed this slide today. This is one of these things. Yeah, and with this I finish my talk. Thank you very much. If you would like to get in contact with us, just give Bettina or myself a call or send us an email, and we will get back to you. You might also be interested in this feature article, which is already dated back in 2018, where we were explaining where the different quantum key distribution space industry and science is, and we have then the other article just issue 2 of this year. So thank you very much.
Okay, so do we have questions? Yeah, one question here.
What is the data rate that you're shooting for in these projects, the Saga project?
Can you repeat the question?
Yeah, I do. The question was about the data rate for the quantum key distribution, so for the key bits. We have looked into this. There are some figures. Unfortunately, I cannot disclose this information because this is restricted information. What I have shown you are the slides where it was written releasable to the public, and these figures are unfortunately not to be released. That's an unfortunate. But if we get an agreement together, maybe for the next phase, I can give you all the details. But thanks for the question. Any other?
Okay, so...
There's one.
I think I can just read.
I will repeat it. That's fine for.
All right. Thanks for the nice talk. I would be mainly interested in this
I know predictions are difficult to make, but building such a system would sound initially very expensive. Is there some way to guesstimate to who this would be accessible in the next 20 years? So is this something that's only going to have military and bank applications for 30 years, or can I expect to get my quantum key distribution in 5 years on my phone?
Yes, thanks for the question. It will be, well, expensive. Well, it will cost what it costs. So if we have looked back to Galileo, this was also a system which is a European infrastructure system. It costs also quite some money. I think we might be a little bit less costly, but it depends really on how many keys in the end we shall produce. So it's scalable. So it could be, it will start with one spacecraft for demonstration, and then it could be up to a very large constellation with different protocols and different orbits. So it could be really a huge one. So I always compare this with Galileo. This is one point, and the customer right now are the institutional customers. So we deliver, that's appliance with the Saga or with the system out of it, the keys towards the commission, to the maybe concessor who is operating the EuroQCI system. And we deliver all the keys there, and then you can, as an institution, can use them to do encrypted communication. And in parallel, we think of doing some commercialization, but this is only the second step. We start right now in parallel to thinking about it. Then the end customer can get use of this as well. But for the beginning, it's more or less institutional. And this is for complete Europe, so for the European citizens in general.
So, yeah, do we have more? Ah, there.
Yeah, thanks for the talk. I assume you will put the quantum key distribution devices on other satellites that are used for other things as well. So are there special requirements on these satellites, and would this limit the application? Okay, thanks for the question.
Yeah, there are plans. Right now we think of a dedicated spacecraft for EuroQCI, but for sure the QKD payload can be put on other spacecraft as well. Well, one condition is that you have an optical terminal. So if you have a spacecraft with optical communication, this is a precondition. So in principle, what you have to do is, just to simplify it, have a QKD payload where the quantum states are generated, and you have to plug it in somehow to this optical terminal, then do some computational task, and then it would work. So in principle, this is, yeah, the precondition.